Acids and bases 2. Properties of acids and bases. Essential ideas. The characterization of an acid depends on empirical evidence such as the production of gases in reactions with metals, the colour changes of indicators, or the release of heat in reactions with metal oxides and hydroxides. The pH depends on the concentration of the solution. The strength of acids or bases depends on the extent to which they dissociate in an aqueous solution. Nature of science. Obtaining evidence for theories. Observable properties of acids and bases have led to the modification of acid-base theories. Improved instrumentation. The use of advanced analytical techniques has allowed the relative strength of different acids and bases to be quantified. Looking for trends and discrepancies. Patterns and anomalies in relative strengths of acids and bases can be explained at the molecular level. The outcomes of experiments or models may be used as further evidence for a claim. Data for a particular type of reaction supports the idea that weak acids exist in equilibrium. Acid or base? Question mark. What are acidic substances? And what are alkaline substances? Well, inorganic acids, the very common ones such as hydrochloric acid and nitric acid, sulfuric acid, etc., are the most common acids used in a lab, I suppose. Organic acids such as carboxylic acids. We've got non-metal oxides. You can see there, phosphorus oxide, sulfur dioxide, sulfur trioxide. Some salts. Only HL students need to know about these, but cations are conjugate acids of weak bases, and cations are transition metal ions. Aluminium 3+2. Alkaline substances, inorganic bases. Most metal hydroxides are bases. Sodium hydroxide, lithium hydroxide, etc. Ammonia is an inorganic base. You've got your organic bases, the amines. Metal oxides are alkaline substances. Alkaline metals form metal oxides, which are alkaline. And some salts too. Anions are conjugate bases of weak acids. And you can see some examples there. Let's look at the trends for PU3 oxides. You can see as you go from left to right, from sodium oxide through magnesium oxide, the alkaline earth alkaline metal oxides are all basic. The pH is greater than 7. We've got aluminium oxide there, which is amphoteric. It can behave both as an acid and a base. It has a variable pH. And you've got all the others being non-metal oxides, and they are all acidic with a pH less than 7. You need to know how to write the equations for the reactions of this lot with water. And you can see there that sodium and magnesium form hydroxides, and phosphorus and sulfur are forming acids. Physical properties. Acids are sour, and just think of the taste of lemons and vinegar. And bases are bitter, tonic water being an example of this. Acids don't really have any particular feel to them, but some bases do. They can feel slippery to the touch. A lot of cleaning products are basic. Solutions of acids and solutions of bases are can conduct electricity. They are electrolytes, and their strength depends on either the acidic strength or the basic strength. Reactions of acids with metals. Metals above hydrogen in the activity series react with acids to form a salt, and they give off hydrogen gas. There's a few examples there. You can see magnesium and hydrochloric acid giving us magnesium chloride and hydrogen gas being produced. Magnesium and ethanoic acid giving us magnesium ethanoate. And zinc and sulfuric acid giving us zinc sulfate and hydrogen. Be sure that you can also write net ionic equations if you are going to write these out. You need to know the reactions of acids with metal hydroxides. They react with bases in neutralization reactions to give us salt and water. So an acid and a base gives salt and water and energy. Some examples we've got here. We've got hydrochloric acid, magnesium hydroxide, giving us the salt magnesium chloride. Water is obviously produced and energy will be given off. With ethanoic acid and sodium hydroxide, it's sodium ethanoate and water and some energy given off. And finally, we've got another example here. Hydrochloric acid reacting with ammonia to give us ammonium chloride and energy. And if you think back to our titration days, acid-base titrations are based on these reactions. And if energy is being produced, obviously these are all exothermic reactions. What about acids and metal oxides? Acids react with metal oxides because the metal oxides are basic and you get salt and water. So we've got sulfuric acid here reacting with copper oxide to give us the copper sulfate and water is being produced. Or another example would be hydrochloric acid reacting with sodium oxide to give us sodium chloride and water, table salt. Acids with carbonates give us salt, water and carbon dioxide. A couple of examples. We've got ethanoic acid, sodium bicarbonate, giving us sodium ethanoate with water and carbon dioxide gas given off. And you've got the sulfuric acid, calcium carbonate, giving us the salt, calcium sulfate, water, carbon dioxide. And again, be sure you can write those net ionic equations. Acids and bases change colour, change the colour of chemical indicators. So let's have a look at this table. We've got red litmus paper, blue litmus paper, bromothymol blue, methyl orange, methyl red, phenolphthalein. You do need to know the colour changes for these indicators. The table 22 does list the colour of many indicators in acid and base solutions, but do remember red and blue litmus, phenolphthalein, and bromothymol blue. So salts is produced by reacting an acid with a base, and you've got to be able to identify an acid and base needed to make a given salt. For example, if you've got the salt copper sulfate, obviously the copper is going to be coming from something that contains copper. In this case, copper oxide would be the base providing the copper ion. And if sulfate, sulfuric acid would be the where the anion comes from. For sodium chloride, the base could be sodium hydroxide, sodium oxide, or sodium itself, sodium being far more reactive than copper. And it's a chloride, so hydrochloric acid would be the acid. Magnesium bromide, hydrobromic acid, and again magnesium is fairly reactive, so the hydroxide, the oxide, or magnesium will react. Barium methanoate, the hydroxide, the oxide, and the metal with methanoic acid. Calcium nitrate, nitric acid, and calcium is quite reactive, so the hydroxide, the oxide, and the metal. And ammonium ethanoate, you've got obviously the ethanoic acid is the acid, and ammonia is the base in that case. Okay, splendid.